Your phone crosses a border. Suddenly, three partner networks light up on the screen, all claiming they can carry your calls. Who gets to choose which one you prefer? You might think the answer is simple. Your home operator sends a preference list to the handset. But that raises a sharper problem. How does the home operator update that preference while you are already abroad, without trusting a channel anyone can intercept or block? That question is the heart of steering of roaming in the 5G core. Before we name a single network function, hold the puzzle. A trusted preference has to travel from home through a visited network and land on your phone intact. If the delivery path is weak, the preference itself is worthless. In the next few minutes, we will watch that sealed preference move through checkpoints: registration, authentication, a home network decision, and a final check the phone itself performs. The goal is not jargon, it is to see why 5G moved roaming steering out of an exposed over the air path and into authenticated control plane signaling. Start with the older approach. The home operator wanted the phone to prefer certain public land mobile networks paired with certain access technologies. Think 5G new radio versus older radio types. That preference list had to reach the handset somehow. One familiar route was over the air. Push the list toward the device on a path that behaved more like a broadcast or management channel than a fully authenticated conversation. Here is the failure mode. If an attacker can intercept that path, they can read or rewrite the preference. If they can block it, the phone never learns what home wanted. The problem is not choosing a preference. The problem is delivering that preference securely. Picture a paper route card taped to an open bulletin board in a foreign city. Anyone walking past can tear it down, swap it, or leave a fake. That is the intuition behind why over-the-air delivery of preferred PLMN and access technology combinations was considered vulnerable to interception and blocking. 5G needed a different delivery path, one that rides the same authenticated control plane the phone already uses to register and prove its identity. So the natural next idea is simple. Stop shipping the preference on an exposed side channel. Put it inside the control plane. In 5G system terms, steering of roaming, often shortened to SOR, is a control plane solution that lets the home public land mobile network update the user equipment with a list of preferred PLMN combinations. Say those words slowly once. Home PLMN is your operator at home. Visited PLMN is the network you are roaming on. User equipment is the phone. Steering of roaming is the mechanism that steers which partner the phone prefers while roaming. Notice what changed philosophically. The preference is no longer a loose leaflet. It becomes cargo inside a registration conversation the network already protects with authentication and integrity checks. That is why the source frames 5G SOAR as a control plane alternative to older over-the-air delivery. We are not inventing a new radio trick. We are reusing the trust the core already builds when a phone registers. Next, we will meet the four actors that carry that sealed route card from home to handset. Draw four vertical lanes, left to right, the UE, the phone, then the visited PLMN primes AMF, the access and mobility function that greets roamers. Then the home PLMN's AUSF, the authentication server function. Finally, the home PLMN's UDM, the unified data management where subscription data and policy live. Why this order? Because a roaming registration always starts at the edge the phone can reach, then walks homeward for trust, then returns. The visited AMF is a checkpoint, not the author of your home preferences. The AUSF answers a different question. Is this subscriber real? The UDM answers, what does home want this subscriber to do, including preferred roaming combinations? Hold one metaphor for the whole sequence. The preference list is a sealed route card. The UE asks to enter. The visited AMF stamps the entry request. Home authenticates the traveler. Home decides whether to attach a new route card. The card rides back inside registration signaling. The phone checks the seal. Only then is the update complete. If you keep that chain in mind, every arrow in the diagram is just one handoff of the same card. The story begins with a registration request. The phone, now in a visited network, sends that request to the visited AMF. Nothing fancy yet, no steering list on the wire from the phone's side. The phone is saying, I am here, please attach me, here is who I claim to be. The visited AMF cannot simply invent home policy. It must involve the home network, so the request becomes the first hop of our sealed card's journey. Not because the card is present yet, but because the conversation that can carry the card has started. This is a deliberate teaching beat. Students sometimes assume steering happens in a separate app download or a silent short message. In 5G core steering of roaming, the update is woven into registration signaling itself. That design choice matters. Registration is frequent enough when you roam, already authenticated and already integrity protected end to end in the ways 5G specifies. By hitching SOAR to registration, home reuses machinery the industry already hardened. Watch the arrow leave the UE and land on the visited AMF. That single step opens the door for everything home will decide next. Next, trust. The visited AMF reaches toward the home AUSF so the subscriber can be authenticated. Think of authentication as checking the passport before anyone rewrites the traveler's route card. If home cannot confirm the UE, it must not push policy that looks official. The diagram shows authentication exchanges bridging the visited AMF and the home AUSF, and through that path involving home subscriber data. Here is the misconception to kill early. The visited network is not the ultimate authority on your roaming preferences. It is a courier and a local traffic cop. Home still owns identity, and home still owns the steering decision. Why authenticate before steering? Because an SOR update without a verified subscriber would be an unsigned flyer again, just dressed in 5G message names. Authentication is the first seal on the envelope. After it succeeds, Home is willing to retrieve subscription data and ask a sharper question. Should we send this UE an updated list of preferred PLMN and access technology combinations right now? That decision lives one lane further right at the UDM. Now the home UDM enters. The visited side, working with home, retrieves the data home holds for this subscriber. Inside that home view sits the material for steering of roaming, whether an update is needed and what list of preferred PLMN/access-technology combinations should be delivered. Access technology matters. Preferring operator A on 5G is not the same as preferring operator A on an older radio. The combination is the real object being steered. Home decides. Sometimes the answer is no update. The phone already has what it needs. Sometimes the answer is yes. Prepare the SOAR information and send it back through the registration path. Visually, treat the UDM as the print shop for the sealed route card. The card is authored at home, not scribbled by the visited AMF. That authorship is the entire security story. If the visited network could mint the list, a rogue visited operator could steer you toward itself forever. Because home authors the list, the visited AMF's job is to carry and complete signaling, not to invent preference. When home says yes, the prepared SOAR information begins its return trip toward the UE inside registration-related messages. Delivery is the hinge. The SOAR-related update rides back through the visited AMF toward the UE as part of registration signaling, not as a random side packet. On screen, watch the sealed card reverse direction. Home UDM through home functions and the visited AMF down into the phone. The content is that list of preferred PLMN and access technology combinations, plus the integrity material the phone will need to believe it. This is the control plane promise made concrete. The same registration dialog that attached you now carries home's steering intent. Pause on a subtlety. The visited AMF sees the signaling pass through. That does not make the visited AMF the source of truth. In a well built chain, transparency of transit is not the same as authority to write. Students often blur those. Say it plainly: transit is visited, authorship is home. When the message reaches the UE, the phone does not blindly overwrite its preferred list. It performs a check, the next beat in the diagram, before it treats the update as real. Without that check, we would only have moved the leaflet from an open board into a nicer envelope. Here is the part that matters. The UE verifies an SOR integrity value, commonly discussed as an SOR MAC style check, before accepting the steering information. MAC means Message Authentication Code, a cryptographic stamp that lets the phone test whether the SOR content is authentic and untampered relative to keys and procedures home, and the UE share through the 5G security design. If the check fails, the phone must not quietly adopt a poisoned preference list. If the check passes, the phone can trust that home intended this list. Address the misconception directly. A first-time learner sees arrows through the visited AMF and thinks, quote, "The visited network programmed my phone," unquote. No, home originated the update. The UE verified the seal. The visited network helped carry registration signaling. Those are three different roles. Verification is how 5G answers the old over-the-air failure mode. Interception that alters bits should break the MAC. Blocking is a different denial, but forging a believable steering list without home's cryptographic standing is what the integrity check is built to stop. When verification succeeds, the phone is ready to complete registration with the new steering state in mind. After a successful check, the UE sends registration complete. That message tells the network the registration procedure, including handling of the SOR information, has finished on the device side. The diagram then shows a concluding notification or confirmation exchange toward the home network. Home learns that the steering information was delivered and processed, closing the loop. Why close the loop? Because steering is not only a download, it is a coordinated control action. Home may care whether the UE actually received and accepted the update, especially when roaming agreements and traffic steering have real commercial weight. Walk the full path once in plain language. Phone asks to register in a visited network. Visited AMF involves home. Home authenticates. Home's UDM decides on preferred PLMN and access technology combinations. The SOR update returns through registration signaling. The phone verifies the SOR integrity value. Registration complete fires. Home gets the confirmation. That is the sealed route card's entire voyage. And every step exists because the open bulletin board path was not good enough. Let us freeze the cast and name what each one is allowed to do. The UE receives and verifies. It does not invent home policy. The visited AMF anchors registration in the foreign network and relays. It does not author the preferred list. The home AUSF anchors authentication. Without it, steering would be unauthenticated theater. The home UDM anchors subscription data and the steering decision. It is where preferred PLMN/access technology combinations are prepared for delivery. Real world example. You land in another country. Two partner networks both have roaming deals with your operator. Your home operator prefers partner A on 5G because of price and quality agreements. With SOAR in the 5G core, that preference can be refreshed through the control plane when you register. With integrity protection, the phone can check. Partner B, even if it is the visited network handling your registration, should not get to overwrite home's preference as if it were home. That separation is the policy point hiding inside the protocol arrows. If you remember only one sentence from this chapter, make it this: home originates, the phone verifies, the visited network relays.